Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to my classes. In this session, I am going to discuss the very important backbone devices and what kind of questions are going to come based on backbone devices we will discuss. So without backbone devices, there will not be any kind of a network. So whenever you talk about the network, then there is a requirement of backbone devices like you see routers or switches or hubs or repeaters, whoever it may be. So some of the important backbone devices, firewall 2. Now let us see. Before entering into the session, our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has brought a wonderful interface to serve the dedicated students, and the content is made up by dedicated faculty members who are senior most faculty members. So utilize this opportunity what the Unacademy is providing and see the best and see that your goal is going to be success. And about myself, Srinivasrao, having more than 15 years of experience in the GATE with the various subjects, and I also had industry experience in the backend side, that is a database and systems side. Also had very good certifications in the backend, that is a DB and a Cisco and Red Hat Linux. So throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of students, my students got completed their post-graduation from India's topmost institutions just by clearing GATE examination. So they also settled in topmost positions in some of PSUs and some are in campus placements. So dear friends, cracking GATE examination is a bit difficult. So you can able to crack just by getting tips and shortcuts as well as guidance. Without guidance, we are not going to clear the GATE examination. So do's and don'ts very much important because the GATE examination is completely objects and completely negative marking based. So in order to get the content from the topmost educators, Unacademy is providing two kinds of subscriptions, Plus and Iconic. So once you become a subscriber, then you're going to see that live lectures, live sessions, mock quizzes and mock sessions and many other things. So according to the Plus program, the following are the subscriptions. So current fourth year students can opt for this, and super long term can be obtained by first and second and third year students. So once you become a super long term, then you're going to see that multiple number of times the different faculty members lectures, you may be in a position to see it. So apart from that, there are recorded lectures, also recorded sessions, you may also use it by using my referral code. So use my referral code to get the admission into Unacademy. So you're going to get a maximized concession. So apart from concession, and I can be your guide. So once you join under me, then I can be your guide and you and me can able to interact in any kind of like discussion of the questions, like you see the sharing of the knowledge and sharing of discussion with any of my alumni who have already completed just by giving GATE examination. So another kind of subscription is iconic. So iconic subscription, there are two subscription prices. The current first and second and third year student can opt, and a fourth year student can opt for this. So what is the benefits of iconic? It is one of the unique program. Once you become member of iconic, then you are going to get a plus stream as usually. Along with that, you are going to see that 1:1 personal coach. 1:1 personal coach you are going to get. So all your, so as it is a 1:1 personal coach, I used to be always interact once you join under me using my referral code. So by using my referral code, you're also going to get some concessions. So my referral code is eligible as a guidance program. Apart from that, you're also going to get good amount of concession on that. And if you are having any queries, just reach us just by filling this form. So once you fill this form, then Unacademy is going to direct a member who can able to assist you to clear all your doubts. And Let's Crack GATE CSE is our YouTube channel. So multiple subjects are going on in this YouTube channel. Subscribe our YouTube channel and hit the bell icon for latest notifications and updates. And use my referral code to get the maximized concession and to get the guidance ship and assistantship from me. So dear friends, let us start. So give your valuable admission into Unacademy. Then Unacademy is going to take care of you just by doing a parenting. So you're going to get 24/7 service either in the form of a content or either in the form of questionnaire or any kind of thing. So let's talk backbone devices. So whenever you're talking about the backbone devices, you may get a doubt that what is the necessity of the backbone devices? For example, if I'm talking that there is a network 1 and there is a network 2 and they want to communicate each other just by exchanging some data. If they are hereby available, then just without having any kind of backbone, I can able to run this. As you are taking a one node here and as you are taking another node here, and no backbone is required. So backbone concept is nothing but what? Whenever you want to connect a multiple number of stations, either using a shared mode or either using a dedicated mode, or whenever you want to form a LAN connection devices, then there is a requirement of a backbone. So according to this example, there is no backbone required. Directly those people can able to communicate each other. And if I am saying that Bluetooth, if you are transmitting some data using Bluetooth just by pairing of your addresses, and here also there is no backbone required. Why there is no backbone required? Because the devices are paired and they are communicating each other. And whenever I am saying that there is a mesh topology, when you are talking about the mesh topology, and here also there is no concept of backbone required. Why? Because in mesh topology, each node is trying to communicate with the other node dedicatedly. So in all these cases, I don't require any kind of backbone devices because they itself communicate each other and it is very expansive. And now if I give an analogy like this, what is that? So a corporate company, you take any kind of a company, a corporate company would like to form a LAN. So whenever it forms a LAN, then there is a requirement of backbone devices. Like, so let me write some of the backbone devices here. Some of the backbone devices we need, like firewalls, and some of the backbone devices we need, that is gateway, and some of the backbone devices we need, that is a router, and some of the backbone devices compulsory switch is a compulsory, and they may require bridges, and they may not require hub because hubs are completely replaced by bridges. And some people will also prefer three-layer switch. But a repeater is also one of the backbone device, how it can able to join two or more networks together. So without having backbone devices, you cannot able to form a LAN, because firewall is going to protect your company. How it is going to protect, I will show you. And a gateway is a protocol converter. You can communicate from any kind of a network to any kind of a network. That means Wi-Fi can be communicated with a wired, and token bus can be communicated with Ethernet. Any sort of network you talk, and that can be communicated with others. That's a gateway responsibility. Router is used to integrate your LANs into WAN. Internet means a collection of routers and firewalls and gateways. And your switch is a LAN forming a device. So there is a requirement of a switch. And a hub is anyhow outdated. But bridges are trying to establish a joint between two or more networks. And a three-layer switch works very similar to advanced than your router. So you want fast routing capability, better you believe in three-layer switch. And ultimately the last one, repeater. Now we want to identify one important thing. This firewall is working under which layer? This is working at application layer. And this gateway is working at which layer? This is also working at application layer. And the router is going to work in which layer? Internet layer. And the switch is working at which layer? Data link layer. And the bridge is working with which layer? Data link. Compulsory one more question. The layer hardware. And hub is a which layer device? Physical layer device. Three-layer switch is a which layer device? Internet layer. Repeater is a which layer device? It is a physical layer device. So once you come to know the standard of each and every device, backbone devices, then you can understand that under which of the layers particular device is going to work. If you look at application layer, the firewall is running means firewall is all layer device. So what is the meaning of firewall is all layer device means? Anyhow it is working at application layer, but it can also work at other layers also, all other downward layers it works. So whenever a backbone device is working at an upper layer, then its services are available at lower layers too. That's why even though it is belongs to application layer, but it can work it onto your downward layers. As I said, that router is internet layer device, but it is also going to work at data link layer as well as physical layer. So whenever I say that a hub is a physical layer device, that is stick it onto physical layer because that is the least layer for us. But whenever you talk about the bridge, bridge is a data link layer device which automatically works in your physical layer. Now we are learning about each and every these backbone devices. Naturally, you will get a question on either firewall or gateway or router, switch. These are the main important areas where you're going to get a question. First, let us see what is the importance of repeater. So when you talk about the repeater, so this is my LAN LAN 1 and this is another LAN 2. The distance between these two LANs are far away. For example, let me say 1000 meters. But according to your Cat 5 or Cat 6 cable, you can go up to maximum of 500 meters. But your distance between this LAN 1 and this LAN 2 is a far away. That's why we are going to believe in here the important concept very cheaper is a repeater. If you go for router, it is going to be costly. If you go for a bridge, it is also going to be costly. That's why I'm going to cheaper one, that is a repeater. What the repeater is going to do, it takes this LAN. The repeater looks like small channel like this, and this LAN is going to be integrated with repeater, and this repeater is further integrated with other LAN. Now what will happen? This LAN 1 can able to extend its distance with the LAN 2. Now from here to here, I can go maximum up to 500 meters. And from here to here, outbound, I can go to maximum of 500 meters. Now the distance got increased. So I'm enhancing to 1 kilometer. This is how you can able to enhance your distance in the network, right? But why people rejects, why people deny repeaters? Because repeater has got by default delay. That's why we don't go for a repeater. But naturally people are still using repeaters. A repeater, the similar device is called as a booster. What is a booster? Let me explain. If you are taking a cable TV, please listen all case studies properly. Computer networks, general knowledge questions you are going to get 1 to 2 marks. So out of a book you need to learn. So node 1, node 2 are far away distance. What will happen if they far away? N1 is a far away to N2, longer distances. So what is the problem when they are longer distance? You know, when you are connected your mobile, if you are far away to your tower, then you are not going to get the signal properly. 5 points drop to 4 points, 4 point drop to 3 points, 3 points drop to 1 point, and sometimes it's a 0 point. So if you are increasing your distance to your nearest network, then automatically what is the problem? Data drops. So slowly noise is going to be increased. Data packets are going to be dropped, which is nothing but indirectly a dropping of data is nothing but loss of data. We also call it as a what? Noisy. So whenever you are increasing distance, automatically the data what you are transmitting in the meanwhile they are getting to be dropped. Before it reaches to the destination, only partial data will be going. That's how you are going to get voice breaks during your mobile phone. Whenever you are talking with something, then overlapping is going to happen or something data is going to be lost. So in order to solve such kind of problems, as we know that the signal becomes weaker after it is traversing to one particular point. So I'm saying that, so initially whenever N1 is transmitting the data over the medium, okay, the signal is perfect. That means the signal not becomes weaker. But when it reaches to some point, when it reaches to some distance, then what will happen? The signal becomes weaker. Initially the signal becomes strengthened only, but once you reach to some point, signal becomes weaker. Once a signal becomes weaker, then it starts dropping the packets, dropping data. Now what do we do? Immediately we will tell to the other party that I'm not getting data properly. Then immediately they are establishing a repeater. What the repeater do? It takes a weaker signal as an input. Up to that point, no problem. But when you reach to that problem, your signal becomes so weaker. So it takes your weaker signal and try to regenerate. That means it is strengthening. It is strengthening it and try to regenerate it. That means you got signal back. This is the concept, and you can able to communicate easily with the other party. So the main responsibility of your repeater is it takes the weaker signal and try to strengthen and regenerate to other party. That's why your cable TV network is one of the example. They are using boosters. What is the meaning of boosters? Boost of the signal. Boost of the signal means what? Up to one particular point, no problem. You're getting a good clarity of data. But once you reach to certain point, then it is starting dropping. We identified that. That means the signal range. I'm talking about signal range. We identified that point and we try to keep a booster there. Then it boost up it and regenerate it. This is the concept of repeater. But what is the problem? If you keep on increasing the repeaters, what will happen? If I keep on increase the repeaters between nodes, so I establish the repeater and which is another repeater is also integrated and another repeater is also integrated and finally it is get connected to the node. So is there any limitation? This is one important question. Is there any limitation to use repeaters? The answer is yes. How many repeaters I should use? So every repeater takes some time to generate the signal or strengthen your weaker signal. That delay is called as repeater delay. And this is also repeater delay. And here also repeated delay. Why there is a delay? It takes the weaker signal and try to boost it, then generate it. That's why that delay is called as a what? A repeater delay. So when I say that repeaters are there between your two of your nodes or in your network, by default it is taking that much time, repeater delay one side. And other side also you will have the same. Repeater delay we want to consider in both the direction because it's a slower device which is trying to take your vehicle signal and try to strengthen it. So this is one point. That's why I don't prefer any number of repeaters. So what is the limitation? According to our network standard, maximum of 4 repeaters you may use it. 4 repeaters we can use. If you use a further, then what will happen? Again you are going to see a concept of what? A dropping of your data. So this is how about repeater. There are some important points are there with repeater. So it is a two-port node. A repeater connects segments of a LAN. A repeater forwards every bit without any filtering because it doesn't have any filtering capability. A repeater does not amplify the signal, just it regenerate the signal. When it receives a weaker signal or corrupted signal and it try to make it to original strength, it's a purely hardware based. So naturally, maximum length of your segment is 500 meters. according to 10 base 5. And according to 10 base 2, it is 200 meters. This span can be extended by keeping a what? Repeaters. And a repeater do not isolate the collisions. It do not have collision detection. It do not have collision detection mechanism, as it is a purely hardware based. That's why a repeater is not at all a collision detection component. So our repeaters are used in the LAN when we consider the repeater delay. By default, we are going to have some time. So this is the ideology of a repeater. So there is a one LAN 1 which is having a far distance with a LAN 2, and both are being combined with the help of repeater, and it is strengthened and regenerate to others. And the second kind of backbone device is hub. When you talk about the hub, it's different from your repeater. Repeater is just a junctioning of your LAN only. But whenever you talk about a hub, it is a LAN forming device. Please understand. Here I am going to give you one numerical question. It is a LAN forming device. That means you can establish a LAN. So several nodes can get connected to your central controller. Hub is your central controller only. So whoever wants to send the data, first you send the data to central controller. So node 1, this is a node 2, this is a node 3, this is your node 4, and they are sharing this hub. So therefore, it is connected a LAN. Now this LAN contains 4 nodes. This LAN contains 4 nodes. So now, when you talk about the hub, this is the first phase. When you talk about the hub, it is under share mode. So your hub capacity is being sharing by multiple nodes. They are not dedicated. They are under sharing only. Therefore, entire capacity is being split according to your number of stations. For example, you talk about I'm having some X limit of hub capacity and which is being shared by 10 stations. Now your capacity is being split among all the 10 stations because hub is a what? Shared mode. Now therefore what happened? So whenever a node is transmitting the data, and first of all the nodes are get to be connected to your central controller, nothing but hub. So node 1 is connected here, node 2 is connected here, 3 is connected, 4 is connected. Now I want to say that N1 would like to send the data. N1 sender. Exactly I want to transmit to N4. N4 is going to be the destination. But once you say like this, what will happen? Whenever N1 released its data, it's come to first hub, then it is a multi-port to everybody. Because it do not know who is a N4. The N4 is connected to which of the Ethernet port. Therefore, what will happen? Hub is as it is under shared mode, it is also called as a what? Broadcasting device. Because it is trying to perform what? Broadcasting to each and every one. That's why I am calling it as a what? Multi-port repeaters. It repeats the same data to each and every port. That's why it is called as a multi-port repeater. Okay. And third important point, according to your hub is, you say, as I already told you, sharing, as I already told you, broadcasting, as I already told you, it is a multi-port repeater because it is under shared mode. It's not a dedicated mode. But switch is a dedicated mode that we will see sooner after. And hub, I am saying that it is a logical bus. What is a logical bus? What is the meaning of a bus? When you are talking about the bus topology, I already taught all these lessons to you. So a single cable is shared by several nodes. So whoever wants to transmit the data and the data is going to pass. For example, one pushed the data onto the media and this data will pass to each and every node and this data will pass to each and every node. That's why we call it as that bus topology is a broadcasting. It is a broadcasting as well as it is under shared mode. In the same way, I can point out in such a way that I can interpret that the hub is a logical bus. Even though it may not be a bus topology, even though you are using a star topology, but the nature of transmission is a what? Bus. So you may get a doubt that why hub is not following a bus topology and why star is following, or why hub is following star topology. Yes, I agreed. Point number 4 is that hub follows star topology. So what is the meaning of star topology? It is a mandatory that all the nodes are supposed to connect to central controller. So whenever I say that it is a mandatory, every node should connect. For example, 4 nodes are there and those nodes are being given wires which are connected to your hub. So whenever you see this kind of a situation that nodes are get connected to your central controller, then it is called as a what? Star topology. But its data transmission inside is a what? Not dedicated. Please understand. Its data transmission inside is a what? It is talking to each and every other port and it is handing over the data to each and every port. Even though N2 and N3 are not in the race to get the data, but they are going to get the data because hub is acting as a what? Logical bus. Its physical topology is a star, but it works like a what? Broadcasting. That's like a bus topology. And another important point, according to hub. So I say hub is a central connector and it do not have any address learning mechanism. It is intelligent, it is non-intelligent device, no address mechanism and no frame filtering and no packet forwarding. These are all the intelligent decisions they are not having by hubs. That's why, because as they are not there, your hub, I can call it as a what? It is not an intelligent device. It is unintelligent device. Its performance is very poor. That's why we don't believe in what? Hub. And another important point is that when the nodes are connected to your hub, if there are any collisions happen, hub is a whole and soul responsible to detect the collisions. Hub is a whole and soul device or whole and soul guy who can able to detect what? Collisions because it's under shared mode. Therefore, what will happen if hub has got n ports? Assume if hub has got n Ethernet ports, if somebody asks you dash number of collision domains. So your ports we are not believing in as they are not collision domain separators. So how many number of collision domains I can say? as your hub itself can able to detect the collision, hence you are having only one collision domain. This is very important question. So even though I'm having a 2000 ports or a 24 ports of hub, I don't mind. As a hub itself only can able to detect the collision, because the ports which are there in your hub are not collision domain separators. They cannot able to deal any kind of collisions, right? That's why. So your number of collision domains are nothing but only one. That's why your collision domain is a what? Decreases, because it do not have multiple number of collision domain separators. So there are two kinds of hubs are available: active hub and passive hub. Passive hub is means only central connector. Active hub means what? It works like a hub as well as it works like a repeater. Both functionalities are there in your active hub. And anyhow, altogether, we confirm the point. We are closing this is that it is not an intelligent device, because no address learning mechanism, no frame filtering, no packet forwarding. All these things are not there because hub is a purely hardware device. That is my closing point. Hub is a purely hardware device which is working at a physical layer. Hub is a purely hardware device. Works only in physical layer. This is the concept. Now let us see its important points. What are there in the hub? Hub is a layer 1 device. It is a multi-port repeater. It is a broadcasting device. It is a LAN forming a device. Its topology is a star, but it works like a bus. It's a purely hardware based. It is under shared mode, not a dedicated. That means your entire bandwidth is going to be shared among by your nodes. They are not going to take a dedicated bandwidth. Apart from that, what are the drawbacks? It decreases collision domain because hub has got only one collision domain. Hub is only one collision domain. That's why you are not having a more number of collision domains. This is one of your gate question. That's why hub is going to decrease your collision domain. Because every port which are there in your hub are not collision domain separators. So it is not an intelligent device because it doesn't have address learning frame filtering capacity, and it do not have buffers also. That's why hub we are not calling it as what? It is not a store and forward device. Very important question. It is not a store and forward device as it do not have what? Buffers. What is a store and forward device? You know. So whenever I am sending the data from the sender, first the central controller is supposed to store for some time. Then after that it is going to be transmitted to your receiver. So your data is sometime is going to hanging in the buffer. That's the meaning of store it and forward it. It doesn't have any forwarding mechanism. So there are two types of hubs are there. One acting as a normal connectivity device. One acting as a connecting device plus repeaters. That means it can able to what? Strengthen your signal. So active hub is means what? The signal is regenerated. Therefore it works like a what? Repeaters. In fact, they have been called as a multi-port repeaters. And if you look at the passive hub, it's just like a normal LAN connector device only. It connects wires coming from a different branches. It do not know any kind of extra point. The signal is just forwarded as it is whatever other guy is transmitting. So these problems we want to avoid just by using the concept of switch. And switch is a layer 2 device. So let me examine the different points about switch. First one, it is also LAN connecting device. Observe, replaced by switches. It's a LAN connecting device. What is the power of switch which was not there in your hub? When I say LAN connecting device, similar to hub only, you are having Ethernet ports, and each Ethernet port is a dedicated. Your bandwidth of your switch is not going to be shared. So now here what is going to happen? Node 1 connected here, node 2 connected here, node 3 connected here, node 4 connected here. Now tell me how many ports you require to connect all your nodes to your switch. It's nothing but I need n Ethernet ports in the switch, because every port is dedicated to one particular node, and it is not under sharing, it is under dedicated. So all the facilities which are there in a hub are also there in your LAN, but powerful than your hub. Point number one, it's a LAN connecting device. Point number two, it is not a shared, it is a dedicated. It is a dedicated central controller. So what is the meaning of dedicated central controller? Which means the bandwidth, the capacity, whatever is there in your switch, the capacity, whatever is there in your switch is not going to be shared. It is going to be dedicated only. So every port can able to take that much of bandwidth because it's not a dedicated. But in hub, it is under sharing. Your entire capacity is being split by your number of stations. But here no. So we are going to take aggregation of your capacity. If each node is providing 10 Mbps, four nodes are connected. So 40 Mbps your switch capacity. It is aggregation. But hub is a what? Splitting. In hub the capacity is being splitting among all your stations, but in switch your capacity is going to be what? Aggregated. You are going to get a beautiful data rate. And point number three, switch following star topology only. But data transmission is also like a star. This is very important. It's a logical star. Data transmission also what? Star. What is the difference? That means data is not going to be passed to each and every node. For example, there are different nodes who are connected to your switch. You assume. Now what will happen? N1 is a connected and N5 is a connected, and other nodes are also active that time. N2, N3 and N4. Now here what is going to happen? Whenever N1 sends the data, it's a logical star. Data exactly goes to the destination. So N1 is acting as a sender and N5 is acting as a receiver, which means the data which is coming from N1, first it goes to the switch and the switch forwards to exactly to N5. That's why it is performing a what? It's not a multi-port repeater. It's not multi-port repeater. If our hub is a multi-port repeater, it's not. It is a logical star. And another important point in your switch is it is a store and forward. Your switch is store and forward. That means switch has got buffering mechanism. Which has got buffering mechanism. So whatever sender is sent, first it is going to store in the switch for some time. Then the switch is going to forward. It has got forwarding capability also. Store and forward. And another important point is that switch is intelligent device. Why it is intelligent device? Because of three important parameters. It know address. MAC address table it will maintain. So it knows that address learning capability. It has got address learning capacity and it has got packet filtering capacity and it has got packet forwarding capacity. So all these capacities are there. That's why hub switch is intelligent device, which was not there in your hub, all these facilities. So what is the meaning of address learning capacity? When you talk about address learning capacity, so it is going to maintain, switch maintains MAC table. Switch maintains MAC tables, media address control addresses. So whenever you connect the nodes, then automatically it takes a one table. The table consists that what is the sender MAC address, what is the destination MAC address. That address is going to be maintained by your switch. So it maintains this table to all the nodes who are connected at that particular time. That's why it knows that who is the source and who is the destination. Therefore, data will go exactly to that particular party. It has got address learning capability. And another one is switch is a collision domain separator. This is given in the previous GATE question. Switch increases collision domain. Why? Because every port in switch is collision domain separator. So beautiful concept this is. Collision domain separator. What is the meaning? I say there are 4-port switch I am taking. That means I can able to connect 4 nodes, 1 and 2 and 3 and 4, and I am following a switch. So what will happen? Every port can able to identify and detect the collisions. That's why as there are 4 ports are there, you are having a 4 collision domains. That's why switch increases collision domains. Hub decreases collision domain. What is the meaning of collision domain? We will see very sooner in this class only. Please hold on. Confine the collisions is a concept of collision domain. So these are the important points about your switch. Why the hubs are not that much popular as comparatively switch? Because of all these points. Okay. So switch is a LAN connecting device. It has got dedicated bandwidth. It is a logical star. And a switch simulates bridged LAN. It deals with the MAC addresses. When I say that it is a MAC addresses, it is a layer 2 device. What is a layer 2? Layer 2 is your data link layer. Data link layer is hop to hop based. So when I say hop to hop based, it only deals with a MAC address, not the IP address. It only deals with a MAC address, not the IP address. So IP address you want to deal means you might have to use a 3-layer switch or a router. But here as a switch is a data link layer device and which is going to only deal with the MAC addresses only. So it supports hardware as well as software functionalities. What are the advantages? So provide parallelism, increases collision domain, because every port has got a buffer, store and forwarding you can do. If there are n ports, then n collision domains are existed. It is an intelligent device because it has got address mapping, frame filtering, and frame forwarding. And a switch maintains address map tables. That means with a frame hardware address, before deciding to either to forward or to drop it. Those kinds of decisions you can take from switches. There are no disadvantages here. Switch is ultimately one of the beautiful device. That's why we are using nowadays switched Ethernet. What is a switched Ethernet? We are taking a manageable switches and try to establish your LAN. So switch functions, MAC address learning, forwarding and filtering decisions, and loop avoidance. There are few types of switches are available. Cut through switch. It's not a store and forward based. Observe. What is a cut through switch? It's like working like a hub only now. Whenever sender transmit data through your switch, whatever you transmit, immediately it is a forwarding to other party. It is not storing. That's why it's a cut through switch. When packet is forwarded to destination as it is received from the source. But store and forward switching is not like that. Store and forward switching is it stores the data, and when the receiver is available, then I can able to use a what? Buffering till there is availability of the receiver, like your WhatsApp messages. For example, I send one message to you. First it is going to be under a buffer. As and when he is available, that is being transmitted to him. So in such case, we want to see that a concept called store and forward. You want to see the store and forward capacity, you need to have the concept of what? Buffering. So there are other kinds of switches are also there. So unmanageable switches. So you cannot able to manage your MAC addresses. That is the meaning of unmanageable switches. Whatever the default parameters are there, those default parameters only you can use. Configurations cannot be changed. But in manageable switches, I can able to inter-exchange the port. I can say that this particular node is dedicated to one particular port only. Even though you are seeing that your cable is exchanged to other particular port, it is not possible because it is dedicated, it is a configured. The port to configuration is there in your manageable switches. I can decrease the bandwidth, I can increase the bandwidth to that particular port. All these kind of manipulations are there in your manageable switches. For example, you see, I want to allocate 10 Mbps to this port only. That means it tunes only 10 Mbps. I want to set 20 Mbps to this particular port. So it tunes to 20 Mbps only. That's what your Wi-Fi routers. When you get a connectivity from other party, then it tunes that how much bandwidth you want to set. And you cannot exchange the ports also. Whatever port is given to node 1, so you cannot change and fix it to others. You will not get the connectivity. These are all the possibilities are there with your manageable switches, right? And the other one is that router. Now we want to deal with IP addresses. When you want to deal with your IP address, you need to have a concept called three-layer device. So your router is a three-layer device. Observe carefully. It is inter-networking device which is mainly used to form WAN and internets. It integrates different varieties of LANs. It has got hardware and software functionalities. As it is working in layer 3, it deals with a what? IP address, and which can also further work in data link layer, which also understand MAC table, and further which works at the physical layer, it try to regenerate the signal. All the three functionalities are there with your router. Let me explain why the necessity of the router. For example, This is Infosys network, and this is TCS network. So some of the people, they want to exchange the data from this network to this network without internet. Please understand. If there is internet, I don't mind. If there is internet, I don't mind. They can able to exchange the data. But I am saying that because internet is a group of your WANs only, wide area network, so you can easily transmit the data from one to others. But I want to say that without internet, I want to use it. Just taking the public IP. We do not want to communicate over internet. With internet means I can able to deal, but without internet I want to form. So how can you do this? I'm saying this is a LAN 1 and this is a LAN 2, and they communicate each other. So when they communicate each other, it's not possible because they are different LANs. When they are different private LANs, they are corporate LAN. They are different LANs. Private LAN is nothing but corporate LAN which do not want to send the data over internet. Please understand. These are called intranets, not internets. Now let us see. I want to transmit from here to here. How this is possible? Not possible. That's why we believe in routers. So we contact the router. Please recollect my previous lecture. We contact a router. Now what will happen? Router is a LAN and WAN connecting capability it has got. Now I'm saying this is your LAN port which is connected to your corporate LAN. This is your WAN port. Now this is also LAN port, and outside I'm going through WAN port. Now what will happen? This WAN port has got the dedicated line, this WAN port has got the dedicated line, and both are connected through exchanges. Without exchange, you cannot able to have any kind of communication. So what do we understand? We understand now two networks are integrated now. And networks are integrated. Now they becomes what? One network. How they can able to communicate each other? So as you are having a private network, you are configured with the private IPs only. And this LAN port is also configured with the private IP. But as you are connected to your exchange, and that too I'm talking about the WAN port, I'm having a WAN IP. Now this port is also configured with the WAN IP only. Wide area network IP. Your router also has got WAN ports as well as LAN port. And now this is connected with the LAN IP. Now you see, from this particular point to this particular point, I can able to communicate. I have got the private IP, I can communicate to my private IP of router. And here to here, LAN IP and LAN IP can be communicated. But this router, the beauty of the router is, it try to have the NATing capability. It also try to have the NATing capability, network address translation. What it can do, it takes your LAN IP and try to put it in what? WAN IP. Address mapping is done here. So now you become a WAN member through exchange. So the private member became a WAN member, and through exchange it tried to contact your WAN. But now you want to go inside to the other network. Again, it is performing a NAT. Public to private will happen. And finally, this guy can able to exchange the data with other LAN. This is the main important role of your router. So what are the functionalities? It connects independent networks together to form an inter-network. It performs routing and it constructs routing tables. It performs a network address translation. It increases the collision domain and limits the broadcast domain. So while data exchange is happening, so MAC address is going to be changed at every hop, but IP address is fixed. This is important point. IP address is not changed during data transmission. Is not changed during data transmission, but MAC address is changed at every hop. MAC address is changed at every hop. Hop means next interface link or next jump. So this is how your LAN and this LAN is integrated with the help of routers. And very similar to router is also very intelligent device. Very similar to router, we are also having 3-layer switch. It is very similar to router, but it is very faster than your router. It's much faster than your traditional router. It is also both the hardware and software functionalities as like this is also works at internet layer. Whenever I say that it is working at internet layer, it automatically works at the down the ladder, data link layer as well as physical layer. So all functionalities which are there in your router, all are there in your 3-layer switch also. Types of routers we are having. Router stands for, it has got the bridge functionality and the router functionality. Core router, they are trying to do the data exchange within autonomous system. Edge router, conversation among autonomous system. So virtual router, when area routers are not able to work, then virtual router is going to work. Border router, exchange data borders of your autonomous system. Backbone router, which is configured to area 0. The other one is bridge. What is a bridge? Bridge is trying to connect a different IEEE format of network to different IEEE format of network. For example, it can done Ethernet to Ethernet, Ethernet to ring. Their standards are different. 802.3 and the standard is 802.5. Packet formats different and the standards are different, but you want to exchange the data, then there is a requirement of what? Bridge. It is a layer 2 device. When I say layer 2 device, immediately need to strike that it is working with a what? MAC address. So bridge breaks your LAN into LAN segments. So bridge is a self-learning. It has got hardware functionality as well as software functionality. So bridge deals with a MAC address, not with IP address. Bridge uses flooding, very important question. It is uses CSMA by CD. And bridge with the smallest number is called a root, and the remaining number which are greater than your smallest number, they are all called non-roots only. A root bridge only forward your packet to non-root bridges, and non-root bridge has to find the shortest path to the root node. Advantages, it also increases collision domain. One of the important point. So bridge maintains a bridge tables. Bridge follows a spanning tree to avoid loops in the network. A bridge does not change its MAC address during data transmission. Only router, when you talk about the router or three-layer switch, whenever you're exchanging over data, then MAC address is going to be eliminated. So drawbacks are bridges are only for smaller nodes. Bridge do not limit the broadcast domain. So this is the bridge. So bridge is intelligent device because it is going to maintain its MAC table, how the data is being exchanged via which ports. So now I was saying that collision domain and broadcast domain. What is the meaning of that? A collision domain is a section of a network where the data packets can collide with one another in the shared medium. So only one device in the collision domain may transmit at any one time. So some are, especially switches, are trying to avoid the collisions which are in the network just by listening that are there any kind of collisions are there or not. So whenever you are having collisions, it try to decrease your network efficiency. So what is the broadcast define? Your broadcast domain is nothing but it is trying to see that logical division of your network where you see that the broadcasting is going to be happened at the data link layer. So collision domains are generally smaller than within your broadcast domains. Collision domains are divided by layer 2 device and broadcast domains are divided by layer 3 device. That's why layer 3 device limits broadcast domain. So these are the important points. Router limits broadcast domain. Hub decreases a collision domain. Hub is not a collision domain separator. If hub is used as a centric device, you are having only one collision domain. When you talk about the bridge, it's a collision domain separator. If two LANs are connected using a bridge, then your bridge has got two collision domains. What is the meaning of that? This is a one LAN and this is a one LAN. Your network is segmented into two LANs and which is incorporated with your bridge. Then this bridge has got two collision domains because this is one hub network and this is one hub network. Two hubs are integrated and so you are using two collision domains. And a switch. We know that switch is going to be a collision domain separator every port, therefore collisions are going to be increased. And a repeater is an unintelligent device because it decreases the collision domain. It did not isolate what? Collisions. Now let us see the very important another device called firewall. What is a firewall? A firewall is used to protect your corporate network from the intruders and other outside networks. If some other outside network people wants to access your content, it's not possible. Firewall is trying to blocking. It is trying to block the network or it is unable to send your data to other side party also. All kinds of restrictions are there in the firewall. So firewall can be hardware and firewall can be software and it is going to work at application layer device. So it is going to work as a what? Choke point, which will not allow you to send the data to outside party if I configure the firewall in such a way, and it is not going to get the data from outside network to your network, and if you are configuring policies like that. If you feel that the data which is coming to your network, if it is untrusted, then you are not going to allow it. Simply we will block and deny it. So these are all the concepts which are there in your firewalls. So it is used to protect information by your internal secure network and untrusted external networks. So all kinds of attacks which are there by intruders can be handled by firewalls only. So this is your private network, this is your internet, and the firewall is going to see that outside data. First of all, it is going to be under scanning whether can I allow you or not. Your data policies are following my firewall policies or not. If you are following my firewall policies, then I will send you, otherwise I will reject you. So this is the concept of what? Firewalls. So what are the firewall capabilities? It defines a single soak packet to keep unauthorized users. It prohibits potential vulnerable services entering or leaving the network. It provides protection from various kinds of IP spoofings. It is also called as a monitor secure related events. It performs audits and alarms also. Audits and alarms can be implemented. When did you log in? What is the site you opened? And which is the computer you are talking? How much time your session is there? All these kinds of functionalities you can able to configure in the firewall itself. So it is also using IP security in the form of what? Tunneling mode. So what are the limitations of firewall? Firewall cannot do few important things like antivirus. Let us see. A firewall cannot protect against any attacks that bypass the firewall. So whenever any kind of a device or any kind of a site which is bypassing your firewall, it cannot able to protect it, right? So a firewall does not protect against internal threats from traitors. So internal hacker, internal intruder, you cannot able to identify. So firewall cannot able to do any virus infected program. So you need to have antivirus for that. So there are few varieties of components which are there in your firewall. Packet filter, application level gateway, circuit level gateway. What is a packet filtering? Packet filtering is nothing but, see, I want to say that whether it is a malicious data or non. So that kind of identifying data is there with your firewall. So when a packet arrives, then packet filtering is going to see that it extracts some information from your header, that whether you are a genuine or not, whether can I able to pass through or can I able to discard it. That is the meaning of packet filtering. So how it identifies that who is the sender, who is the receiver, what is the TCP or UDP port, and what the type of the message you are having. All these kinds of information it extract before it sends or before it receives it. And the next one is application level gateway. You can also call it as what? Bastion host. So user contact gateways using application and the request is successful after authentication. So if you are one of the member in that, then I can able to throw you. So like FTP, Telnet, SMTP, HTTPs are your for examples of application level gateways. So some people will call that I have got a server and I want to issue internet to the clients using a proxy. So what I am doing? I am trying to see that your client will connect it to your servers and I am having only one internet connection only. Only one internet connection, but I am trying to give with the help of what? Proxy address. So when I say the proxy address, then you can able to contact the server and it is trying to authenticate you. Whatever request you are giving, everything is recorded in your server only. And the last one is circuit level gateway. whether can able to establish the path or not. So if I deny, your path is not going to establish. If I accept, your path is going to establish. So it does not allow end-to-end TCP connection if gateway deny it. So once the TCP connections are established, the gateway TCP segments from one connection to other connection without examining the content. That's why before you establish the connection, you need to be very careful whether to establish or not. So the security function determines which connections to be allowed and which are to be disallowed before establishing your circuit level paths. Now let us see some practice questions on this. First question. What is a multi-port repeater? So one mark important questions all these are. The multi-port repeater is nothing but what? Hub. Because data is forwarding to each and every port which are connected onto your hub. And next question, what is the function of repeater? So identify what is the function of repeater. The repeater is going to work in layer 1 device, we know. So it works at a layer 1 device. So therefore it is wrong. And it is trying to regenerate the signal in order to reach the longer distance. It may be the correct. The repeater is used to increase the network performance by avoiding collisions. No, it is not a collision domain separator. It is not a collision domain separator because it is a dumb terminal. So it cannot able to isolate the collision. It cannot able to detect the collisions. Therefore, this is a main function, regeneration. What is the function of a bridge? Bridge try to split your single LAN into multiple LAN segments. Bridge is a layer 2 device. Bridge works with a MAC address. Bridge uses a shortest path. Bridge uses a spanning tree protocol to avoid the loops. Bridge is a plug and play device. Bridge is hardware and software based. Bridge is intelligent device. Let us see what is correct. Bridge inspect incoming traffic and decide whether to forward or discard it. The bridge is a device that connects two or different similar LANs and it operates at layer 2 of OSI model. The bridge is used to increase the network performance by avoiding collisions happen in one LAN to affect to other LAN. So these are all the functions of your bridges only. It works at layer 2 and it is trying to split the two LAN segments and they can able to combine together. And bridge inspect incoming traffic and see that whether to allow or disallow. This is your GATE 2019 question. So beautiful question. Let me explain. So I want to connect 15 machines using 8 port Ethernet switch. He is following switch only. So 8 ports are there in your switch. So port 1, port 2, port 3, 4, 5, 6, 7 and 8. So 8 port switch means 8 nodes I can connect, no doubt. 8 ports I can connect. So node 1 I can connect, node 2 I can connect, and node 3 I can connect, node 4 I can connect, and node 5 I can connect, node 6 I can connect, and node 7 I can connect. But I have to leave one port. Why? We will see it. This is your switch, one switch. And still I need to connect a total 15 machines now. Only 7 are connected here. So one more switch I am taking. And here also the switch consists of 8 ports. And I can connect node 8 and node 9, 10, and 11 and 12, 13, 14. I have to leave one port here. So altogether how many machines I connected, please see. And another 8 ports which I am taking. So switch. This is switch 1 and switch 2 and switch 3. Connected in a within a LAN. That means they are all belongs to same LAN only. This is very important point. I want to see that all supposed to be in the same LAN and they try to communicate each other. That's why I need to give a uplink to this particular switch to this particular switch. So one port is reserved for them. Because this switch would like to communicate with this switch, therefore there is a requirement of what? Attaching your Ethernet cable into this port and into this port. Therefore, you can, out of 8, you can reserve only 7. And out of 8, you are reserved only for what? 7 only. But you look at this. I need to keep one more port here. That's why you cannot have in this 7 systems. I can keep only here 7 nodes I can connect and 6 nodes only I can connect because one port is connected as a uplink to the switch 1 and one port I am using uplink to the second switch. Uplink means what? Interconnecting of your switches. Therefore, to this port, the node 14 and node 15 are connected. So how many switches are there? Altogether, 3 switches are needed. Actually, everybody feels that 2 switches are sufficient because 2 switches means 2 into 8 port 16 systems I can connect, but it is wrong. So this is what is the hierarchy or structure of what? Your switch. And next one, what is the function of your hub? Hub is a LAN forming device, simple, and so it is a broadcasting device because it do not know that who is the destination. Please understand. So when a frame is received, it knows exactly which port to send it. No, it do not know that who is other connected at what port because it is lagging behind of address learning mechanism. And a frame is passed along broadcast to every node. This is perfect. So whenever a hub is transmitting data, this data will goes to each and every particular point. So this is, and routing capability is not there with your hub. Routing capability is only with the router or 3-layer switch. So that's why that is also wrong. Next question. What is the function of a switch? So switch also do not have routing capability, either router or 3-layer switch only. A frame is a passed and no, because switch knows that who is the destination, exact party I know because it is maintaining a MAC table. So this is your answer. I know that who is the source and I know that who is the destination because in my MAC address I know that there is a source address and destination address field. So the data will exactly goes to the destination, but which was not there in your hub because your switch maintains MAC table. Next question. A repeater takes a weaker or corrupted signal and try to regenerate it, strengthen it. Try to strengthen it. So this is your answer. So which of the following best statements towards hub? All connected systems are in a same broadcast domain but different collision domains. Same broadcast domain, please understand. It may be a correct. So all connected systems are in a LAN in a same collision domain but different broadcast domain. All connected systems are in the same broadcast and collision domains. And all connected systems are in their own broadcast and collision domains. So what is the best in this option is, and hub itself is a single collision domain. Please understand. When I am saying that a hub is a device which you are using as a centric device, you are having under only one collision domain only. Only one collision domain. So where is another only one collision domain? So this is your answer. Yeah, this is also. So only one collision domain and same broadcast also. Our answer can go for this. So every port on a switch defines, we know, collision domain separator. Which of the following is a networking device works in the internet layer? That is a data link layer, not internet layer. Data link layer device, bridge is a layer 2 device and a hub is a layer 1 device and the router is a layer 3 device and a switch is a layer 2 device. Therefore, data link layer means layer 2 only. This is a 1 and this is a 1 is your answer. So a station being a member of a bridge does not know about the existence of the bridge is a transparent bridge. If switches are used to replace the hubs on a network, what is true? Switch increases the collision domain. Hub decreases the collision domain. In hub, collision domain is decreased, but in a switch, every port is a collision domain separator. Therefore, collision domains are increased. A network bridge table is used to perform the following: mapping of MAC address, forwarding frames exactly to the outbound ports, filtering, discarding capabilities are also there. So all the above are the bridge functionalities. So a bridge is a layer 2 device which can access only physical address. Physical address nothing but MAC address, also called as Ethernet address, also called as hardware address. So what is a false regarding bridge? This is true. Bridge reduces collision domain. This is false because bridge increases collision domain. Bridge is used to connect. Yes. Bridge reduces collision domain. Yeah. This is only false because I already told you, when you say that your total LAN is split into two LAN segments. So this LAN, I am saying that one collision domain, and this LAN I am saying that one collision domain. If they configured with a hub, when I use the bridge among them, then bridge has got two collision domains. That's why bridge increases what? Collision domain. So this is a very good question. 10 Mbps Ethernet LAN, 4 ports and 10 Mbps Ethernet LAN are connected through bridge and their data rate is, average output rate is 1.25 Mbps. He is asking find the number of stations. In bridge, how many nodes are there? So you understand now. The solution is bridge total capacity how much? So 4 ports and each port is taking a 10 Mbps. So this is a 40 Mbps bridge. Now n stations are there with a data rate of 1.25 Mbps throughput. Data rate is nothing but throughput in this particular 40 Mbps. Therefore, what is your n value? Your n is n into your 1.25 Mbps throughput is equal to 40 Mbps of your bridge. So your n is equal to 40 Mbps divided by each station is providing this much data rate. So what is your answer? 40 by 1.25 is your answer. So total these many stations are there in your hub. And the last question. Suppose 20 stations are in your Ethernet LAN. This time n is equal to 20. And all these stations are connected to 1000 Mbps of switch. So what is the bandwidth is available to each station? So if I am using hub 1000 by 20 nodes, and every station has dedicated bandwidth, therefore 1000. This is That's it, my dear friends. This is about backbone. Surely one mark question you will expect in the examination. So we will meet in the today's session, that is a 7 p.m. to session. So in that session, I am going to discuss the complete questionnaire on MAC layer like CSMA, CSMA by CD, FDM, TDMA, and Ethernet. So all these kind of questions we are going back of binary exponential back of algorithm we will discuss in the today 7 p.m. session. We will meet at 7 p.m. Thank you for all your support. Please join for in-depth questions and in-depth knowledge and different varieties of test series. Please join into Unacademy using my referral code Sankara. Then I can able to give you all my 100% effort to you once you join in the Unacademy using my referral code. So thank you for all your support. We will meet in the today's session 7 p.m. Don't miss Mac questions. Thank you very much.